and welcome back to Doz's Television Workshop. This is the first part of a little series I'm going to do called Mending the Micros. We're going to be looking at some vintage 80s home computers, and we're going to be putting them right. So what have we got to look forward to? Well, start with this, of course. This is our Altair 8800 clone. There's nothing wrong with that, works perfectly, and if you want to read more about that, you can do on the website. See the link below. So yeah, we're not doing that. I just thought it would be nice there flashing its lights at us. We've also got a Sinclair ZX Spectrum's 48K model. We've already repaired that one. Again, details are on the website. That had a power supply problem and an issue with the tape loading. There was a capacitor that was giving us problems. Anyway, that's now working, so we can cross that one off the list. We've got some Commodore stuff. Commodore, brilliant stuff. My favourite. The VIC-20, a friendly computer. I bought that one recently. It's faulty, good. I only buy them faulty. There's no fun in one that already works. So that we'll look at putting that right. That came with the C2N cassette unit, and that's a nice early one. That's the sort of one you got with the PET as well. The squarer sort of design before it went lozenge shaped. I also got some lozenge shaped C2Ns about, so maybe we'll have a look at those as well. So that's the VIC-20. We have of course got the Commodore 64. There's a bread bin hiding away and down the back here. That I bought faulty. I don't know what's wrong with it yet. Haven't had a chance to have a look at it. And then we've got this, the Commodore SX64 executive computer with its built-in keyboard and built-in colour screen. Great fun. I've had this for many years, and yeah, we need to have a look at that because its keyboard doesn't work, and when you can get the keyboard to work, I know the floppy drive won't read, and so that's got a good few issues to put right. So that'll be exciting. It is basically a Commodore 64 on a jiggled printed circuit board. Layout's completely different. Of course, it's got inbuilt power supply and monitor, but that'll be exciting. Moving across to the other side, we have got the Commodore 128. Of course, the Commodore 64's later and bigger brother. 128K of memory, 80-column graphics, and let's face it, if you have one of those in the 80s, what did you do as soon as you switched it on? You typed Go 64, played your Commodore 64 games, and wished you'd waited around a couple of years for the Amiga. But hey, great machine. We've got a couple of 1541 disk drives. Readers of the website will have seen we've repaired the power supply on one, which was dead, but at that time we didn't have any machines, Commodore machines, to test them with. So obviously those will work with the 128, the C64 and the VIC-20, and probably the SX64 as well. So we can test those out. That'll be good. This is a thing. It's filthy dirty. It's a BBC Model B+. I presume the difference between the B and the B+ was the B+ is 128K of memory. So there we go. I think it was the sort of last of the line of the Model Bs before they went to the BBC Master Series. And then last, but by no means least, the humble ZX81, and I think we're going to start here because it's a lovely simple machine, and as yeah, it should be a fairly straightforward repair, I'm hoping. I think this came to me sometime in the late 80s. So we'll get that apart and we'll have a look at that. And also with it, we've got the ZX Panda. Oh, the marketing people must have loved things like that. That's 16K expandable RAM. Does that mean it's not already got 16K in it? I don't know. I've never used it. But so we've got that as well, so we can run some 16K programs on our ZX81. And that's it. The way I plan to do this, I'm not going to do them all one after the other, or, you know, we'll break up every now and again and maybe look at a television set or something else. So yeah, it's not just going to be computers. But anyway, there we go. Let's start off now with the ZX81. Right, one ZX81. We've also got the Z expander that fits in the back, and we've also got a very exciting looking manual. Yeah, ZX81 Basic. Look how comprehensive that is. Absolutely brilliant. So we've got a book, and we've got 2 cassettes as well. So that's good. Can you outwit the gruesome gulper that seeks out, gives chase, gulp, accelerates and devours? ZX81 16K of RAM. High-speed machine-coded action. Yep, you can guarantee that is going to be some kind of Pac-Man clone. We'll see if we can get that to work. What else we got? Catacombs for 16K ZX81. That seems to have got folded up the wrong way around. From JK Grieve Software. Simply the best ZX software available. Oh, marvellous. That was when the games industry was really in its infancy. I wonder if we've got a date on there. 1981, I should think. There we are. So we'll see if we can have a go at that. Oh yeah, there you go. Copyright 1981. Oh, that's worrying. That says tape 3. Number 3? Does that mean... Oh, well. Maybe they're supposed to be... Oh, games tape 3, look. A multi-level graphics adventure. Games tape 3. Maybe that's not the whole thing. Oh, well. Never mind. It doesn't work yet. That's going to be our first thing to have a look at. So, what have we got? Now, I seem to remember I got given this as a non-worker way back in the 80s. So, zoom in a little bit. There we are. So, our friends across the pond got the Timex, Sinclair Timex machine, which was very, very similar to this, except for I think it had 2K of memory. Weren't they lucky? So, yeah, right. This has got no screws in it. The keyboard ribbon is ripped off, which probably, yeah, that's stuck in there. So, we're going to need a keyboard. I think I've got one of those, though, so that's all right. There's no screws holding the printed circuit board in either. And here, written upon the heatsink, is the words No K, written in Chinograph pencil in my own fair hand. No K. And that means we've got no cursor. The cursor on a ZX81, it's like a little blinking inverted K. In fact, does it even blink? Can't remember, it's been that long. But there we go, we have no K. So I think the first thing to do is fix the no K. What else we got on the board? Let's just have a little look. We've got a power socket, which is a 3.5mm mono jack, as are the ear and mic sockets for the cassette deck. There is a sort of phono socket out there, RCA phono socket. That's for the modulator. That's a UHF modulator, single channel, fixed on or around channel 36. Okay, so we have got the ROM, this chip here marked Sinclair Research. There we are, copyright 1981. This over here is the RAM, and fitted in this one is a Mostec 8226. In the middle here, the brains of the operation, the NEC Z80. That's a D780 C-1, excuse me. Oh, next to that, we have the Ferranti ULA. This one's actually dated 1982. It says 8233 on it. Let me bring that up so you can see. Yes, there. 8233. So that's the, I've got it around the right way, wouldn't it? There we go. 8233. So that's the 33rd week of 1982. The ROM is the 39th week of 1982. Ah, Mostec. That's better. There's the word, the letters I was looking for. It's a 4801 AN 4118 AN RAM chip, and it's 8226, so it's the 26th week of 1982. And what have we got on the Z80? That's the 29th week of 1982. Look at it. There's almost nothing to it. Almost nothing. What's that? 4 ICs and a voltage regulator. The 7805. There's a transistor over there. Can't remember what that one does. Right. Let's give it some power and see what it does. I don't have the power pack for it. So what we shall have to do is we shall have to use my lab power supply. One of the first things we're going to do is check the 5 volts is present. So let's get on and do that. We've got the PCB, we've got the trusty workshop monitor, we've got the lab power supply. We shall set that up in a minute. But first, I really want to look at this PCB quite closely before we go applying any power, just to see if there's anything we should be concerned about before we supply power. So there we are. We've got a close-up of that. Can't really see anything other than this bit of membrane left in that keyboard connector. So I think what we'll try and do is just fetch that out. These aren't like the sharp ones where they tend to fold their teeth back. These are quite okay. All right, that looks all right. So there we've removed that bit of damaged keyboard ribbon. Right, okay. So having a close look at the board. How those capacitors look. Well, they really do look like new. Whether they're any good or not, who knows. So there we are. Right. Regulator heatsink is, it's reasonably tight. It's not bad. Sometimes they do work loose, and yeah, you need to tighten them up. It will run for a short time without a heatsink, but it's far from ideal. Right, okay. Looking at the back, okay, it is illegible. R91 pop, is that? Anyway, what can we see? Joints all look a bit bubbly, but they always did on these boards, even when they were new. That looks to have spot there. Can you see that? I don't like the look of that. Looks like it might have been a bit warm. As do these down here, or have they just been soldered up? This might be evidence of previous work I've done back in the 80s. A bit of flux gluing on there. Not very nice, but I don't think it's going to give us any real problems. Okay, edge connector. Obviously, you've seen some action in its time. It wants cleaning up, certainly before we use it. But we're not worried about that at the moment. We just want to be able to get a signal out of it. Right, I think it's time to throw caution to the wind and power it up. The resistor looks a bit odd there, but it's always been there since factory. But it hasn't got a through hole point. It's just sort of resting on the board. You see that? Anyway, let's get some power up it. So what are you going to want to do? Aerial lead, so RF modulator, UHF channel 36 with this machine. Presumably, the Europeans had a VHF modulator, maybe, or even and certainly the American Timex machine, because it would have had different timings to generate an NTSC-ish signal. So yeah, maybe that's. So we don't know if this regulator is any good at the moment. So I haven't got. I don't think I've got a 3.5mm jack. Worth me checking in a second. And I think, don't hold me to it, I will test in a second, that it's the centre, the tip, is negative, but I could be wrong on that. So let's check that first. Let's see if I've got a 3.5mm jack for a start. If I have, we will use one. If not, I will just work out the polarity and tack a couple of wires on for now, and then we'll order up the right jack. Moving on. What's that? Oh, it's the big drawer of connectors. So let's see if we've got a 3.5mm mono or stereo jack. Would you look at that? That'll do nicely. So, yep. Draw away for later. Okay, so we've got a jack there. So we better obtain the polarity. I think this is pre-enjoyed. Yes, it's been used before. Right, let's quickly disassemble that. Unsolder the existing cable. Take the right. Let's got that into a usable state. I tell you what, I'm plugging it into the wrong thing. This jack is 9 volts, 9 volts DC. Let me just check on the side of the case. Double checking. Yes, ear, mic, and 9 volts DC. 9 volts DC. It's the front one. That's okay. We haven't applied any power. No machines were harmed in the making of this video so far. Good. Okay. So we need to work out which is negative and which is positive. So you can almost guarantee that the case of the modulator will be negative. Oh, and I'm doubly wrong because the tip of the jack is in fact positive, and we can confirm that because this is the 7805 here. So if we go between the centre pin, or the tip brother, and pin 1 of the regulator, regulator's pin 1 is input, and it's there. The output is 5 volts. Okay, so there we go. Right at the minute, I have my power supply. Now the power requirement for the ZX81 is 9 volts at well, it's 9 volts. I don't know what current it consumes. I shouldn't think this regulator is capable of much more than an amp. So 9 volts comes in and is simply regulated by the 5 volt regulator. So I've got 9 volts on my power supply, and okay. Right at the moment we are consuming 375 milliamps. What we now need to do is see if it's producing a signal. So go to the TV, press menu, we need to go to setup, select, country UK, system is PAL. Let me move the camera up so you can see what I'm doing. Oh. Yeah, let me just move the camera up. There. That's better. Where was I? Menu, down, setup, country UK, sound system I, manual tuning. What do I just want? Manual tuning. I'm on channel 30. I had channel 37. Channel 36. Oh, now we've gone too far now. Come back, come back. Channel 36. Okay, not only have we got no K, but we've just got, oh, we've got a little bit of interfering sort of going on. Just some pickup from the modulator by the look of it. So, right, we have got some action, but not much. So, ROM is just perceptibly warm there. The RAM is stone cold. Z80 is stone cold. ULA is rather warm. That's worrying because we probably won't be able to get one of those, not quickly anyway. But anyway, let's do some diagnosis and see what's happening. Right, let's get into the repair and make some measurements. Quick look at the circuit diagram. I think the first thing we need to check is for the presence of 5 volts. So our power adapter plugs in here. In this case it's my bench power supply. 7 to 11 volts. Goes into pin 1 of our 7805 regulator. Pin 2 is ground. Pin 3 should have a nice 5 volts on it. Lovely. That 5 volts feeds lots of things. Pin 40 of the ULA. Pin 11 of the Z80 CPU. Pin 24 of the ROM. Now the RAM on this model is IC4. It's a single 1K by 8. Earlier things had 22114 1K by 4s. In which case we'd need to be checking 5 volts on pin 18. As it is, we've got the single chip, but we need to be checking for the presence of 5 volts on pin 28. Excellent. I suppose we have got a carrier, so I was thinking we need to check for presence of 5 volts on the modulator, but we must have that. Wouldn't take a second to check it though, because we have got a UHF carrier coming out, but that voltage needs to be somewhere in the region of 5 volts, so let's check for that. I'll switch the power on. Right, so I'm going to use the ground of the modulator, and I'm going to measure pin 1 of our 7805. There we go, 7.86 volts, 7.77 volts, so around there coming in. And pin 3 should have 5 volts, 4.86, well, close enough for government work. Right, the ULA was pin 40, so let's make sure we've got 5 volts on pin 40. There we go, 4.86, close enough. On our Z80, it's pin 11, which is down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's that one there. 4.85 volts, how lovely. The ROM was pin 24, 4.83 volts, and the RAM is pin 28, 4.85 volts. There is no issue with our 5 volt power supply. All well and good. Right, back to the diagram. And okay, let's check for some activity. First thing we ought to really check is the clock signal. So the clock signal is derived from this 65 megahertz ceramic oscillator. It's not a crystal. Now these, back in the day, used to suffer a little bit in television remote controls. They were all ceramic resonator devices to clock those, and physical shock, and they used to break and render the remote dead. But so we need to make sure that is actually resonating. Feeds pin 35 of the ULA. Some magic occurs in the ULA, and the signal is divided down to 3 point something megahertz out of here through this buffer transistor, and then feeds pin 6 of the Z80. So let's arm ourselves with the oscilloscope and check for that. Right, so our oscilloscope probe, and we shall probe pin 6. So we should have a sort of 3.5 megahertz-ish square wave there. 1, 2, 3, 4, 5, 6. Okay, we need to adjust the time base a little. 1, 2, 3, 4, 5, 6. Adjusted it too much now. Anyway, it looks very much like it's present. Yeah, okay, it looks a bit like a shark's fin at the moment. The probe's on ×1, so it's not due to probe compensation. That's probably what it looks like. But again, do you know what? That's close enough for government work. 3.22358 megahertz. Yeah, I'll buy that. Okay, so we have a clock signal. Back to the schematic. Clock's good on pin 6, so pin 26, that's a reset pulse. So when the machine is first switched on, this is 5 volts here. This capacitor is discharged. So as it's charged up from the 220k, via the 220k resistor I should say, from the 5 volts, this starts off at 0 volts potential and then will rise up. And as soon as it hits a certain point, the microprocessor comes out of reset, because it's active low, the reset line. It comes out of reset, and then the address bus is set to location 0, which is bound to map to the ROM. It gets its first instruction, executes that, and carries on. Brilliant. And obviously it starts booting up and reads the keyboard, and everything else starts up and starts running. So let's make sure that we have a reset pulse on pin 26. So I'm going to switch the machine off. That pin 26 also, rather conveniently, is the positive end of C5. So there's C5. Oh, there we go. I'm not quite sure whether we'll capture this. We may need to alter the time bases on the scope cam again, but let's power up. Okay, there we go. We saw that rise up. So let's slow the time base right down. The important thing here is we can see it starts off at 0 and then rises up to reset the computer. So as long as it's on or near 5 volts, the micro has reset and it should be doing things. Let me slow down even more. That's interesting. Let's do that. Look. So C5 is discharged, switching on, and there it is. So our microprocessor is reset and is doing things. It's interesting, that supply look. It's looking a little bit spiky. So that's encouraging, because that might mean that we've got some activity on the buses. Okay, back to the schematic. So we mentioned the first address the Z80 is going to attempt to read is 0. So we'd expect all these to be low anyway. So what I'm going to do is, I think we need to look at one of the data bits, because that will be coming from the ROM and making its way to the Z80, and it goes via these resistors, so that's quite convenient. We can hook on to one of these and then have a little look at see if there's any data on there. That's good, let's do that. So what do we got? We've got R7 to R14, unsurprisingly. It's 8 bits wide. R7 to R14. First one I can see here is R12. I shall hook onto that. So there we are. Oh, come on. Gently, gently. That's it. It's hooked on. So let's apply the power. Oh, so turn the time base back up again. Apply the power and see what happens. And a big fat 0. Oh dear. We have no data. All right. Okay. So if we've got no data, let us just confirm that there's no activity on the address bus. So I do really want to look at A0. Does that go via resistor? Oh, it does. Look, R26, 1K. Let's see if we can find R26. 23, 24, 25, 19, 18, 26. Or was that 28? The legend's not very clear, is it? Let's have a look at that. And once again, we have got no activity on there. Oh, right. So, we've got no address and we've got no data. So, what's happening? We could have a number of things going on. It could be being loaded down by any of these chips. So, we could have a faulty Z80. We could have a faulty ULA. We could have a faulty ROM. We could have a faulty RAM. So, yeah, I think the first thing we need to do is to pull the RAM chip. It'll still look at the ROM for its data, so that's okay. Let us pull the RAM chip. And come on, edge pop. There we go. Lovely. So we've pulled the RAM out. Let's put the power back on. I want a data bit again, really. R12 we had. There we go. R12, power up. And still nothing. Okay. That's annoying, isn't it? Now, I don't think if we pull the ROM out, obviously address 0 will contain nothing, and nothing will happen unless the ULA is doing something on 0. How are we ever going to know that? We're not, are we, without knowing intimately how this circuit starts up. However, if I pull that out and we get activity, that means the ROM is indeed faulty. So that's not a bad call, is it? Let us, and it's socketed. So what's the worst that can happen? Oh, come on. God, dear. Been in there for years and years. Right, let us power up. And we have no activity. All right. Okay, so it could be the ROM. It could be the Z80. It could be the ULA. We don't think it's the RAM. Now, what have I got? This is the next way to look at it. What have I actually got that we can replace? I don't have a ROM. I have a RAM. In fact, I probably don't have a RAM. I don't have RAM. I don't have a ROM. I don't have a ULA. I do have a replacement Z80. So, let's get that out. We shall socket it because it's polite to do so. Yeah, and we'll swap them out and see if that puts our problem right. Okay, out the desoldering tool. Right, Z80 removal. There it is. Hallelujah. Let's just hope after all that work it was faulty. Have I wrecked any of the traces? Yes. One. Oh, just let's point at it. Just there. You can just see pin 4 has lifted. We shall find out, and we shall put a wire link in that one just to make sure he's good. All the rest are just beautiful. Isn't that wonderful? Yeah, that looks good. So that pin 4, let's just look at putting a wire in there. Put a socket in, put a new Z80 in, and yeah, let's see what happens. One replacement Z80 CPU. What's the date on there? 38th week of 1990. Spanking. One socket to put it in, 40 pin, wide spaced, because it's polite to do so. Normally I like using a turned pin socket. Unfortunately, at the moment, a turned pin socket is more money than a Z80 CPU. So we shall put up with an ordinary one. Now I've got to deal with this track I've lifted. So it's pin 1, 2, 3, 4 of the CPU, and you can just see that is lifted there. So what I'm actually going to do is I'm going to actually pull that off. I'm going to put a wire in the other side. The chances of me getting that in and it not shorting things out, or runs the risk of shorting something out, will not be helping us one iota. So it's coming out. Here it is, gone. And what I'm just going to do to help identify that via is just bubble some solder through it. Pin 4, so that one there. That solder should look nice and shiny both sides. Okay, so, and it is 1, 2, 3, 4. It's the 5th via down. So spin the board over. And using my blue Sharpie, 1, 2, 3, 4, 5. It is that one there, and you can see the blob on it there. So I'm just going to paint that blue for the time being. And then we're going to fit our socket. So pop him in. Cool, get in. There she goes. Good, that's fitted nicely. We shall hold that in with a blob of blue tack at each end. Quickly tack in the corners. Not that there has to be any quickness about it, but hey. And then the tedious task of soldering it up. Okay. Now, over here somewhere, I have a reel of grey wire. This is RS's wire wrapping wire. It's a single-stranded thing, and it's just the job for making up little links like this. So, how long do we want it? Not very long at all. In fact, that piece would have done uninsulated. So let's just get an uninsulated section, tin it up. Smash in. And it's pin 4 to the blue blob. 1, 2, 3, 4 to the blue blob. And that should complete that circuit where I broke the track earlier. Just going to use the scalpel. The trick is, if you're cutting this stuff with a scalpel, is not to push down too hard on the wire. Just use it as a sort of bending radius, and there it goes. Brilliant. There's our socket. Put that away. And here's our CPU. So this, by the way, is a 3D printed leg sizing tool. It's on Thingiverse. Brilliant. So if your CPU is a bit virgin, hasn't been in a socket before, you'll probably try and find the legs are a bit wide. So just give it a little squish in the leg bending tool. Used to have one with bearings on it, and you sort of rolled the chip between the bearings, but of course it was only ever good for one size. That, dual-sided, just the job. So, alright, let's see if we can ease this into its socket then. Beautiful. Great. So, I'm not going to replace the ROM and the RAM just yet. I'm going to see if there's any activity on the data bus between the ULA and our new CPU. Just because I haven't done it before. So I'm just going to put that up, and then we'll put the ROM and the RAM in and check that. Right, let's hook up the scope and look at the see if there's any data in between these two. I don't expect there will be, because we won't be executing any code, but I'm interested. So humour me for one moment. Right, made myself a bit of a better power lead this time. It's still connected to the workshop power supply. So we've got our scope connected to our data bus. And yeah, let's see if we get any activity. Of course, we've not got the ROM or RAM in, but that's where I want it. So let's see if we get any activity. Oh, we do. Well, that's remarkably good news. So now if we pop in our ROM, lovely. Let's just see if we get any different activity. Yeah, very much different. Okay, looks like we're running code. Let's pop the telly on, reconnect that. See if we get... Oh, hang on a minute. We have got some kind of activity on the screen. We've got a lot of data activity as well. Okay, right. Well, let's pop the RAM in. Go for gold. I think I've got two pins folded over. Oh no! No, I haven't. They just look like they hadn't seated in. Huh. Power on. Cool. Is that a K I see before me? Now, the ZX81, its video output is interesting to say the least. So let's have a little go at fine tuning. Oh yeah. I just don't know whether you can see that. Let me try and zoom this camera in a little bit. Oh. Can you see that? K. K for cursor. Blimey, we might have fixed it. All sorts of interesting activity going on the oscilloscope as well. So yeah, it looks like it's running. That's great news. So a Duff Z80 after all. That's good. That really is good news. Okay, so now the picture's pretty awful. Like I said, the ZX81 not famed for its video quality, especially on an LCD telly such as this. It's yeah, not really the right thing at all. Right, so we've got a few jobs left to do, haven't we? First thing I'm going to address before we tackle the keyboard is the appalling UHF output. I think it would be far better to make a modification to make this have a composite video output. And we can do this so it's a little bit reversible, not the easiest job in the world. And it's very, very simple. We only need sort of 3 parts. First thing we need to do is to get the lid off the modulator, which is not often easy. It's just a push fit on, but it's quite it's quite on there, quite tight. You don't want to do it with your fingers because it hurts your fingers. Right, so we can see modulator. I suspect this is the oscillator, and this is actually the bit that creates the AM TV part here. We're going to basically lose that, disconnect it, and we're going to use the 5 volts, I'm going to call it a video signal, the pseudo video signal from here, and we're just going to mount a transistor in the top, a single transistor buffer amplifier, and send the composite video out on the existing RCA socket. So yeah, right, let's see if I can get a zoom in on that for you. Down we come. Okay, it's a good shot of the modulator. Oh, go on, focus. You know you want to. Maybe we've got a bit too far. Let's come back out of it. Oh, that's lovely. So I'll just go over that again. This is the oscillator section of our modulator. And this is the modulator properly. So you can adjust the frequency of it by tweaking that coil slug. very slightly, but we're going to do away with that. So we're going to need a warm soldering iron. Almost any NPN transistor will do. I happen to like the BC547, you may have noticed. So that's what we're going to use, a BC547. Any sort of NPN small signal transistor, probably a 222 will do it, a 2N3904, something like that. Any of those, but I'm going to use a BC547 because it's my favourite. Okay. First things first, I want to try and gently remove the wiring from the BNC socket here. So that appears to be connected via this resistor. And I'm just seeing if it's connected to anything else. No, I don't think it is. So I'm just going to warm that solder junction up and take that off. Yep, okay. So we're just going to move that out of the way a bit. Now the wire that's supplying 5 volts into the unit goes down to the PCB. Unfortunately, we can't sort of get at the bottom of the modulator. It's soldered in here. I guess we could unsolder it completely. Should we do that? Would make a tidier job of it, wouldn't it? And I can then unsolder that wire. Or I suppose there's nothing wrong with me. So this is the wire in question here. Going through this, that's the video input. The 5 volts is there. So let's see if we can't heat that wire up from the top and actually pull it out of the board, I suppose. That would be okay. And if we ever want to revert it back again, we could always take the modulator apart and solder it back in that way. I'm just going to try and be a bit cheeky and just pick that out. Yeah, so I'm not quite sure I'm getting enough heat on there. Let's try fluxing it up a bit with a bit of fresh solder. So I'll just pull it out of the can now. Am I still anywhere near his shot? Right, so that has actually removed that. I'm just going to check I haven't shorted it back to the case, because that would be bad. No, that's good. Okay. So that's got a 5 volt feed there. And we also want to do the sort of same with our video connection here. I think I'm just going to cut that. So there's our video connection. I'll try and get my head out of the way of it as much as possible. Seem very soft, these wires. Okay, so there is. Oh, it's stranded. Good Lord. What appears to be stranded. I thought that was a single strand of copper. It's not. It's a stranded wire. Who knew? Right, so we need to create a simple buffer amplifier in here. So yeah, tidy that up a bit. Okay. Just tin that up a little bit. The success of this modification, I should say, does really depend on what sort of ULA you've got fitted. What revision of this is, because when it makes this sort of pseudo video signal, it does depends whether it's got a back porch. It creates a back porch signal, or it doesn't. So yeah. Right, 3 is the collector, and the collector goes to our 5-volt supply. So that's over there. So let's come out a little bit. Just gonna tin the leads of my transistor up a little. Right, so I want the collector to pick up my 5-volt supply. You could do this, you know, on the outside of the can and run a lead out and leave the modulator in place if you want. I just think this makes it quite neat. So here's my 5 volts. I'm going to need to hold that out of the way a little bit. Better. Alright, so that's my collector connected to 5 volts. I'm just going to check for shorts again, because this feed through can be problematic. No, it's fine. Yep, absolutely fine. Okay, so the middle lead of our transistor in this case, if you're using a different transistor, your mileage may vary. Check your pin out. That goes straight to the ULA, so that's driving the base. There we go, connected. And last but by no means least, the emitter is our video out. I'm sure you've got a great shot of the back of my head again. So the emitter is goes to, let me get this right, it's not quite video out, is it? We will need a series resistance in there. That goes between the can, quite a big iron to do this. Those Metcal's very good. Is it going to be enough to do that? Yep. Okay, we need 100 ohms in between the emitter and ground, about 100 ohms. Right, so let me zoom in again and show you what we've done. Oh, wrong way. Too blurry. Too blurry. There we go. Can we get that in good focus? Yes, nearly. It's come out a little bit more. That's good. Okay, so we have got our 5 volts coming in here, going onto the collector of our transistor there. This is the replacement transistor. The base goes straight to the video pin, which is the one not on the pass-through capacitor. That dashes off to the ULA. And then the emitter, 100 ohms, to ground. Now we need to couple the emitter to the output stage, to the output socket. And there's all sorts of conjecture about what value to use to get the right brightness. it's all a bit of a fudge. So we're going to try a 22 ohm resistor to start with and see what it looks like. So this is 22 ohms. And this we're going to connect between the junction of the transistor and the 100 ohm resistor and connect it to the center pin of the output jack there. So let's trim this down a little. I'll put a little foot on it so I can make a good strong junction. We'll get that all nicely tinned up. Oh, there we go. Right. Oh, no, nearly. Doesn't want to take. What's going on? I suspect that centre pin's getting quite warm. That's it. And there we go. Right, let's just trim that. Oh! I should cut the sneeze out. Right, there we go. Let's dab us hold on there. Puts those all together. Yep, that's taken beautifully. So there we have it. 5 volts, video in there. The emitter resistor is 100 ohms and then 22 feeding the center pin. So this is my video lead into my TV. I'm going to power the TV on. So now we can push that straight into there. We're going to need the power reconnected. Treated myself to some more of these little 4mm crocodile clips that I love so much. So I'm just going to use a black one because I appear to have mislaid my black one. These were not cheap from RS. There are only people that appear to do them, but an expensive day was had. I have got 2 packs, a new pack of red and a new pack of black. Those are the old reds for now. Right, switch my power supply on. TV is already on AV1. Let's just hook the power supply up. Okay, and let's power up and see what we get. Oh, hang on, I want to connect the power supply to the computer. That would help no end. Let's zoom out a bit. There we go. So there we are. That's my video out now connected. Switch on. Oh, look at that. A much clearer display. I wonder if we need to tweak that just slightly, that 22 ohm resistor. So it's quite dark, isn't it? So maybe we need to go a little lighter. There's a few jail bars on there, as they're called. Not sure we can do anything about those. Although, to be quite honest, I wonder if putting the lid back on the modulator will help. No. There we are. It is what it is, but it's certainly a better picture now. We want to brighten that up a bit. So yeah, let's move from 20 ohms down a bit. What have I got? Oh, I'm 22 at the moment, aren't we? So this is the bit where I haven't really got a decent selection of resistors. What's that? That's 15 ohms. Let's try 15 ohms. I suspect this will vary a little bit with the DV as well. So I tell you what, I'm just going to hook that one leg off there and then tack the 15 ohms across just in case we've got to do it again. and then when we're happy with it, I shall put it in permanently. Right, just tin the resistor legs up a bit. Doesn't want to stick to that centre pin. Oh, it really doesn't want to stick to that centre pin. Just dab on there. I wonder what's going on with that. That's got it tin it up a bit more. Right, let me apply some power to that. That's better. We've got a nice definition of K there. So a little zoom in if we can. And the gel bars are a lot less pronounced as well. Oh, this camera's really in the wrong position for this. Let me just so we move it around a bit. There we are. So yeah, it's really quite nicely defined there. Right, let's make that new resistor permanent. We could go a little lower. I'm happy with that. This white background never really was quite white. They always were a little grey, even on an analog set. So let's make that nice and permanent. Little foot on it, so we've got some surface area for the solder to stick. And there we go. If we ever wanted to, I'll just zoom in on that again. If we ever wanted to restore this back to UHF operation, only be a matter of taking that transistor out, reconnecting that resistor from the modulator to the center pin, and hooking back up the 5 volts and the video back to the board underneath. But I think that's quite a neat little modification, and we don't have to run any extra leads or drill any holes in the thing or for another socket or whatever. It's just there. So yeah, got to pop that lid back on. There we go, perfect. Right, next job is the keyboard. Keyboard replacement. So it's a flat cardboardy type keyboard, membrane type affair, and the problem is the sort of membrane becomes very, very brittle, and you can see it's cracked and split here. You see, we could probably save this one by cutting it off here and reshaping that, and again cutting this one off, or we could just do ourselves a huge favour and fit this very nice replacement membrane. This one came from RWAP software. Don't know if they're still going. Oh, there's a URL there. Let me just punch that in. See if they are still going. rwapsoftware.co.uk. RWP for all your retro computing needs. So, yep, they are still going. If I click on ZX81 there, 30 years old and still going strong, and a bit now. So, there, yep, you can still purchase the membrane on Sell My Retro, and there they are. They are currently £15.80. There we go. I have to say, I bought that one a good while ago. In fact, a friend of mine bought it for me as a gift for Christmas one year, which was very nice because he knew I had a ZX81 with a Duff Spectrum with a Duff keyboard on it. So epic. Right, now we've got to this was just stuck on with self-adhesive, which is, I mean, let's be honest, that's lasted really well. So we've got to sort of get that off. So we need to work our way in under there to start with, and sort of just pry the keyboard off the plastic front. And you can hear that, but it's sort of peeling away. And once you've sort of done that, you can get in under here, and you can see it's starting to come away from the case. You see those marks where I've been pressing with the tweezers there. So let's see if we can get in on that edge there. Oh yeah, we're in on the edge. Oh, we're in. We're well away. Keyboard, by the way, it does come with some very comprehensive instructions on how to fit it, but it's very straightforward, even more straightforward than the Spectrum one I did, which we documented on the website a while back. All right, oh look, we can really get some heft behind it now. Oh, and it's leaving the sticky bit behind, which is suboptimal, because we're going to need to clear all that off. So I'm just going to try and pick up on that. Just take it with it. It's easier if it all comes off in one go, because it's obviously less of a mess to clear up afterwards. I often have to replace this type of membrane, even today, on modern broadcast equipment, and 2/3 of the job is clearing it up, so you've got a nice clean base for the new membrane to stick onto. It's especially important on some of the gear I do, because it needs to be partially watertight. Oh, it's amazing really that after all these years these things are still available. Somebody's gone to the effort of getting them made. There's our old keyboard. Here's our new one. Let me just check it all fits nicely. It's just going to fit beautifully. It's going to be great. By the time we smooth that corner in, that's going to look fabulous. And more importantly, work, unlike the old one. Let's put the old one up out of the way. Right, the moment of truth. The sticky back doodah. Peel it off. And stick it in place. Come on. Oh dear. I wonder if using the tape trick will work. Should we try it? Get a bit of ordinary tape and stick it to the backing and then pull, and hopefully the tape pulls the backing off. That's the idea behind it. It's always one of those things. I wonder how many hours of my life I've wasted trying to peel tape off or find the edge of a reel of tape. Or opening carrier bags in supermarkets. That's another skill that has eluded me all these years. Of course, it's not sticking enough. No, it's going to have to be the hard way. Okay. Once you've got a corner started, of course, it just comes straight off. Come on. Oh, I think I'm in. Yeah, look at that. Oh, beautiful. All right. Carefully insert the membrane, the ribbon cabley part. I'll try and get this in as square as possible. Oh, it's pretty good. Oh, we're happy with that. Very smart. Jolly good. Okay, so now it comes down to reassembling the machine, which it's going to be a little bit challenging as we don't have any screws for it. It appears those were lost many moons ago, so I will try and find something sensible. I'm just going to put a screwdriver on this regulator very quickly, because whilst it was tight, it was not uber tight. So it's, there we go. So that lives like that. So it's all held in place. There's nothing to hold the PCB to the bottom cover, just all in one. Right, okay, well that's easy enough. Let's pop. I'm not going to put the screws back in just yet, especially as I haven't got any. Let's just gently pop these membranes, these ribbon cables in. Connect our machine back up and check we've got a working keyboard. It's not going to be so easy without the screws on in it. There we go. Right, okay. Power supply is switched off at the moment. There's the connector. Oh, the excitement. Right, there it is. So, if I type 10, print. Oh, yeah. Andy, N-D-Y, don't type too quick. DOS.blogspot.com space semicolon. How do I get a semicolon? It's down here, that's it. Chitting. New line, there it is, loaded into memory. 20, go to 10. This uses keywords, by the way. You'll notice I'm not pressing a PRINT for print. You just press P, same as the Spectrum. So let's zoom the camera in so you can see what's going on. There we go. Zooming in. So 10 print, andydolls.blogspot.com space. And there we go. So if we do that, it should fill the screen with andydolls.blogspot.com. How wonderful. 510 means mission accomplished, basically. Oh, I've got that all tangled up. Let me just disconnect that in a moment so I can move that wire out of the way. There we go. Brilliant. List. There's our program. Run. In fact, is 5 out of 10, is that scroll? No, it isn't. It did come to an end at the end of the screen. But a nice clear display. That's just super. Pleased as punch with that. So, yeah, let me just new that out. So, there is another mod we can do. Now, we have got the ZX Panda 16K expandable RAM. And I'll show you how that works. Or worked, because I'm not actually going to use it. I shall explain all. Oh, that's it. So what happened was, on that, let me just connect this keyboard again. There we go. What happens is your RAM pack fitted onto that edge connector right at the back here. You can see that there. And what happened is you'd be typing away your 16K of program or your 16K game that we used to get. Magazines back in the day used to list a listing, and you could go in and type them into your machine, and yeah, you'd be typing away, and this would wobble. That connection would become intermittent on here. The whole thing would get corrupted, and oh, the frustration was immense. Often the blasted listings in the magazine were wrong anyway and didn't run, or you made a typo somewhere and it didn't run. But oh, we learned, you know, I learned so much by doing that. But yeah, the 16K RAM pack was just not very good. I want to see what's in this one actually. But anyway, we're not going to be using that, and it's because we can fit that. This it's a CY62256L. It is 32K of memory. Now, I'll explain how the memory works on the ZX81. So you remember I said earlier that the Z80 CPU starts up and it looks at a memory address 0, executes that command and gets on with life. Memory address 0, as I said earlier, was in the ROM. Now, the ROM is 16 kilobytes. So the first 16K of memory is ROM. The 17th K in this instance is our memory chip. Now, this is almost pin for pin compatible. With machines with the 2 RAM chips, you take those out and you fit this socket and you can fit that in. We've already got this socket fitted, so we're 2/3 of the way there. And it really is just a few minutes. We need to tie some address lines up and put a link in, I believe. And we can have not 32K of RAM. Because the addressing doesn't quite work properly, we will get an extra 16K of RAM. Now, I may have a foggy memory of this, but I don't think anybody did anything bigger than the 16K RAM pack, except for, I believe, Memotech did a 32K one, and they had some trick address, and I don't think all that memory was available to BASIC. I think BASIC's only capable of addressing 16K anyway, and I don't know if there's any software available for more than 16K. Certainly not popular anyway. So this is a really nice solution to doing away with this. Let's fit this chip and give ourselves 16K of internal RAM. First thing we're going to need to do is to remove our dear old 1K RAM chip. So, as it is going to be made redundant. Bless it. After all these years of sterling service. There it is. I'm sure it'll get recycled at some point into some other machine. We're just going to check the socket's the right size it is, because obviously this is only 24 pin. Right, so this 32K chip, we're going to bend some pins out. I have seen people cut the tracks on the board. There's no real need, and we can do it this way. So the pins we need to bend out are 1, 21, 23 and 26. So pin 1, pin 1, and pin 1, pin 21, 22, 23, 24, 25, 26. Okay, so we'll just wick those out. There we go. That's the easiest way. I'm going to fit the chip in the socket. Excellent. I'm going to take the case away for a moment. Okay. Now we're going to need some wire. I'm going to use the, this is RS Kevlar coated super wire wrapping wire. Just the job. Don't matter. As long as it conducts, we really don't care what it is. So let's just nick the end off that. I shall obtain the universal vice. Where have I put it? One universal vice. Right, let's tin that up. Make our connection to pin 1 to start with. So I shall place that wire on there. Struggling to see here. Which glasses have I got on? Oh, I've got the right glasses on. Don't get old, folks. Where's my magnifiers gone? Ah, there they are. Lovely. So there's pin 1. Now pin 1, A11, which is D1. So let's go to the pointed end of D1. Try and get it to a sensible sort of length so it's neat and tidy inside. There we go. Yeah, that's all right. Right. Tin these pins up as well while I'm here. That's it, that's all of those tinned. Let's do the nearest one to us next, which is A21. Pin 21. It's D2. Let's just flux D2 up a little bit. Work better if I use the solder. So that is pin 23, which goes to D3. Doesn't actually matter which way around you get these address lines, I don't think, because the RAM will of course always read back what's been written to it, so it doesn't actually matter if you get the address lines mixed up, because it'll just write to the appropriate address, and when it goes to read it back it'll get the right result. That's D3. And last but by no means least, pin 26. Okay, now that's it. Simple as that. So let's just power our machine back up, make sure we've not got any glaring errors in that. Yep, okay. Does take a little bit longer to boot up, don't you see that? You can't see it because the camera's off. I'll show you again. And this is because it has actually counted up. Ready? It's 16K of memory, so took a little longer for the cursor to appear. That's encouraging. That means we might have 16K of memory, but we're going to need to prove it. So let's put this machine actually back together, find some screws for it, and then we're going to run a little program to prove that we've got some more memory. Okay, I found some screws, put it all back together. Now we need to just check our memory is available. So I've typed in this little line of basic, which is print peak 16388 plus 256 times peak 16389. That should return 32k, so 32768. 32768. Brilliant. Now the reason it's returned 32k is it's measured the 16k of ROM, of course, and then the 16k of memory out of that 32k RAM chip that it can spot. There you go, a 16k ZX81 all upgraded and ready to go. All we need now is to make a mains power supply, I suppose. That's going to be a simple enough task. And maybe load some games up. Why not? Anyway, that'll do for this bit. Thanks for watching, and come back soon. Next micro, I reckon, is going to be the VIC-20. So we've got a broken one of those to repair. But in the interim, we'll do a bit more analog stuff. I think maybe a telly or something, just to keep the interest varied. There we go. Like, subscribe, push the bell, leave some comments down below if you wish. Tell your mates, it's all good fun. Thanks for watching, and see you very soon. Cheers now.
Thank you.